All right. So today, the topic we're going to talk about is limiting reactant. And that topic may sound challenging, but as long as you understood stoichiometry, it should be pretty straightforward. So I always start off with this joke. This one comes from the Lord of the Rings franchise. One does not simply do stoichiometry without finding the limiting reactant. And so that's our goal today, is to kind of look at and go through how to find the limiting reactant and tackle these limiting reactant problems. So if you notice, right away we look at this equation here. And this equation should look fairly familiar to you because we've done a lab or two with it. We have sodium hydrogen carbonate, acetic acid forming carbon dioxide, water, and sodium acetate. And you notice what's different about this from the other problems we've done is we have 10 grams of sodium hydrogen carbonate and we have 10 grams of acetic acid. So because we have two reactants, we need to determine which one will actually dictate what goes on in the equation, like what's going to actually be our final product. And the answer to this is pretty straightforward. Whichever one makes the smallest amount of product, that'll be the reactant that'll get consumed first. And therefore, once you run out of that reactant, you're done. So instead of needing one T-chart, you're going to need two. And you're going to need one T-chart for the sodium hydrogen carbonate and one T-chart for the acetic acid. So for the sodium hydrogen carbonate, I start off with 10 grams in the upper left. We've done this multiple times where you can convert to moles. This is the molar mass of sodium hydrogen carbonate. If you look back at the equation, it's 1 mole of CO2 to 1 mole of sodium hydrogen carbonate. The molar mass of CO2 is 44.01. We multiply everything on top. We divide by everything on bottom. That'll give us an answer of 5.24 grams. Now, normally we'd be done, but we need to look at also the 10 grams of acetic acid. So here we look at the acetic acid. I have 10 grams of acetic acid. The molar mass of acetic acid is 60.05. It's a 1-to-1 ratio. We have 44.01 grams. So we'll do all the top multiplied together, divided by all the bottom. That'll get us an answer of 7.33. Then all you do is compare the two. And you notice the sodium hydrogen carbonate is going to get consumed first because we can make less amount of CO2. So because sodium hydrogen carbonate makes less CO2 than the 10 grams of acetic acid, this has to be the limiting reactant. So we're going to run out of sodium hydrogen carbonate first. We'll have leftover acetic acid, and therefore the amount of carbon dioxide, the maximum amount I can produce, is this 5.24. So here I have a different equation. I have nitrogen gas plus hydrogen gas going to ammonia. And given 50 grams of nitrogen and 50 grams of hydrogen, how many grams of ammonia will you generate? So if you're working on this, you can pause the video, go and try to do this problem with those two T-charts, and I'll show the answer on the next two slides. So go and pause the video and do the work now, and then come back. All right. So here is all the work from this. So I have 50.0 grams of nitrogen. 1 mole of nitrogen is 28.02 grams. And then from the balanced equation, 2 moles of NH3 is going to go to 1 mole of N2. We'll take 50.0 divided by 28.02 times 2 times 17.03. That'll get us 60.8 grams of ammonia. Then for this one here, we'll take 50 grams divided by 2.016 times 2 divided by 3 to get us 17.03. That'll get us 282 grams of ammonia. Because the 60.08 is less than the 282, this is limiting and this is excess. So the maximum amount of ammonia I can generate from these two reactants is 60.8 grams NH3. And again, that's it. Once you understand all you need is two T-charts, you're going with the lowest one. Limiting reactant isn't that much more work than stoichiometry. All right, that's all I have for today. We'll spend more time covering this topic.